On Earth, we are used to our years lasting way longer than our days, and because of this, it doesn't come naturally for us to imagine how in other parts of the universe, years and days can be very, very different from what we're used to. I want to have a look at the extremes of what a year can look like in this video. A look at some of the longest and shortest years that we know of. Let's start off close to home. Mercury has a pretty short year, only 88 Earth days, which is the shortest orbit that we know of in our solar system. And very interestingly, due to the way Mercury rotates, one day on Mercury is twice as long as its year. Yes, that's exactly 2 years in its solar day. So should anyone ever live on Mercury, you would have to switch around the way of thinking when it comes to describing a shorter reference of time. But it's kind of cheating to say a year on Mercury takes half a day, when it still takes 88 Earth days. So let's skip to Earth timescales as a point of reference. Outside of our solar system, most exoplanets that we know of have really short years, and that's because of the way we detect the majority of exoplanets. There are instruments that look closely at thousands of stars at the same time, looking to see if an orbiting exoplanet passes in front of its parent star, causing the star to dim ever so slightly from our perspective. In order for us to confirm the dip in brightness is caused by an exoplanet, we need to see the pattern of dips in regular intervals. So if an exoplanet does transit a star, but its year takes 2 Earth years before it transits again, then we need to be constantly monitoring the star for many years before we can confirm that the dips in the star's brightness are caused by the exoplanet. On the other hand, exoplanets with really short years, like a few days or week long, can be confirmed as exoplanets very quickly. This means that most exoplanets that we know of take only a few days to orbit. The famous TRAPPIST system exoplanets all orbit their parent star within 1 month. The closest planet to the star takes only 1.5 days. So out of all these thousands of exoplanets that we've discovered so far, which one has the shortest year? Incredibly, there is a pulsar out there, which has a planet, although it could also be potentially the core of another collapsed star, which orbits around the pulsar in only 48 minutes. How can this happen? Well, not only is the orbiting object extremely close to the pulsar, but it's also moving very fast. A neutron star is also very small, at most only around 30 kilometers across, yet it is incredibly massive, so much that its gravity even bends light around it. So a fast-moving close object can stay in orbit because a neutron star gravity is strong enough to keep it there. Although you may say this is cheating again. I mean, a pulsar isn't really a star, is it? More like a star remnant. So what about a main sequence star? In this case, the shortest year that we know of goes to K2137b, a planet that's year lasts only 4.31 hours. Because it is orbiting a main sequence star, the Earth-sized exoplanet is surely orbiting within the star's atmosphere and will eventually either be ripped apart by tidal force or fall into the star completely as atmospheric drag slows it down. On the other end of the scale, the longest year that we know of belonging to a planetary mass object is this beautifully named planet. This Jupiter-type object's year lasts roughly 1,000,000 years. Although there's another type of year that lasts even longer than that, and that is what we call a galactic year. In other words, the time it takes to orbit the galaxy. For us, that is roughly a mind-boggling 250 million years. So, assuming the Earth is 4.5 billion years old, that makes Earth a galactic teenager, only 18 galactic years old. And the fascinating thing is that there will always be galaxies out there that take even longer to complete one rotation. Our galactic year would be comparatively short. So there we have it, the longest and the shortest years out there.